Hello everyone, welcome to Geeks for Geeks. I am Ayush Shukla and I am here with the practice session of Biwizard contest, that is Biwizard 6.0, and today I will be discussing the computer fundamentals questions. So uh, be with me, and so firstly I will be explaining the text pattern here. There is a slight change in the text pattern this time. So this time you will be getting three coding questions, and each 100 marks, and you will be getting 20 quiz questions. So here 10 quiz question will be of computer science fundamentals, and 10 questions will be of aptitude and reasoning, and you will be getting 90 minutes for all these questions, and you have to solve within the time. So you can expect the coding questions of easy to medium type questions, and for quiz questions you will be getting basic questions. If you are coming with the uh, computer science fundamentals, you will be getting the mainly the theory based questions, and if you are considering the aptitude or reasoning questions, there will be you will be getting the questions of the standard topics. So that will be the pattern here. So now I will be discussing the computer science questions today, and that is 10 questions. So let me begin with the so you can join me on the menti.com, and that is here mentioned, www.menti.com. And if you open this link, you can paste this code there, and then you can join me with the quiz, so that you can answer here, or you can answer in the comment section also. So I will be checking while the discussion also, so you can answer the questions, and I will for each question I will be taking a pause of around 1 minute for yourself to answer. After that I will be discussing the solution. So are you ready, or can you confirm if you are okay with that? You can connect with me on the quiz using this menti.com, www.menti.com, and you can copy paste this code, that is 80854692 in on this page, and you can connect to me and answer the quiz with me. So if you want, you can join, or you can answer in the comment section also. Okay, so let me begin with the very first question of the quiz. So here we have got the question, that is the very first question: what is the possible number of binary trees that can be created with 3 nodes? And we are given the first order representation of those nodes, that is given the sequence NML, where the when the traverse in post order. So here there is a condition that we have to find all such possible binary trees where the post order traversal will be NML, and there are 3 nodes. So you have to answer how many possible binary trees are there. So you can answer on the menti.com, or you can answer in the comment section also. So I will be waiting for you. Okay, let's begin with the solution part here. So let me explain on the question here. So clearly first we need to understand what is post order traversal. So post order traversal of a tree is clearly uh, here we have the left of subtree, then right subtree, and then we have the root. So this is the clear post order representation of the binary tree. So suppose we are given the binary tree as let's take consider the example 1, 2 and 3. So for this post order representation will be firstly left subtree, then right subtree, then root. So here the post order will be 2, 3 and then 1. So here we are already given the posterior traversal, that is let me consider the case, that is NML. Okay, so here we are already given the posterior traversal NML, and we have to make all such binary trees such that its posterior traversal will be NML. So we can have 5 possible combinations. Let me draw those combinations. Those are here. Let me write. So let's consider this example. Here L and N. So first example can be this. Second, we can have skewed binary tree, that is L, M and N. Third, we can have though that skewed binary tree in right side, so the same uh, L, M and N. Fourth, we can have let me show you this. Fourth, we can have the binary tree as L, then M and N. So L, M, N. And the fifth one, that is similar mirror image of this. So L, M and N. So L, M and N. So for all these 5 combinations, that is first, second combination, this is third combination, fourth combination and fifth combination. For all these 5 combinations, we have the posterior traversal, that is N, M and L. If you can find, suppose let's consider this. So here we have the posterior traversal, left, then right subtree, then root, and here we have only the left subtree, and then we'll be moving to the root, and then we'll be moving to its root. So here NML. Similar in this case, right subtree, then we'll be moving to its root, and then we'll be moving to its root. So NML. And for this, we'll be having the right, then root, and then it's to its root. And similar in this case, so for all these combinations we have the NML. So for this particular question, we have the answer as 5. That is 5 combinations we can have. So moving to the next question. Here we have been given the question, that is the posterior traversal of a binary tree is given, and we have to find the possible pre-order traversal. So let me give a 1 minute pause, and then I will be discussing the solution. Okay, let's discuss the solution of this question. Here we are given the let me write the first, given the posterior traversal, that is already given. So here we are given O, P, Q, R and S, T. Suppose this is the given posterior traversal, and we have to find the pre-order traversal of this. So we clearly know that posterior traversal is firstly left, then root, sorry, left, right, and then root. So we clearly know that from this given order, that is T will be the root of the given binary tree. So we'll be considering T as the root. So let's consider this. Then in this part, some part will be in the left subtree, and some part will be in the right subtree. So considering the example, let's consider OPQ in the left subtree, and consider RS as a right subtree. So here OPQ will be left subtree, and R and S will be right subtree. Now we clearly know that for each subtree will be again following the same condition, that is the rightmost element will be the root node, and the other will be its children. So considering the same example, let me draw it again. So T here will be, now Q will be the root, and O and P will be the left and the right subtree. So O and P. Now we'll be doing the same for this. So here S will be the root, and R will be in the left or right subtree. It can be anywhere. So considering this as the binary tree, let me write its pre-order traversal. So pre-order here means that is a root, then left, and then right. So pre-order here means this. So for considering this as the base case, so here will be the pre-order traversal will be T, then we'll be moving to its left subtree, and here Q is the root, so Q will be there, and then we'll be moving to its left, and O will be there. Then since there is no more node in the left or the right subtree, so we'll be moving again to the root and then moving to the right subtree. So here P will be there. Now left subtree is completed, so we'll be moving to the right subtree, and here again S will be there, then R will be there. So clearly our output will be TQO PSR. So let's see which here the third example, that is TQO PSR. So this is the correct answer. That's what we have to written here. Okay, so now we'll be moving to the next question. So here we are given the theoretical question, which of the following pure traversal on a binary tree can build the tree uniquely. So it is clearly that if we are given the post order and the in order traversal, or the pre order or the in order, means any of the order that is pre or post with the in order traversal, it can identify the tree uniquely, because in order traversal you get to know where is the root, means you get to know the left and the right subtree uniquely, and in post or pre-order you will get to know what is the root. So here with the combination of pre-order or in order, or post order or in order, you get to know the unique traversal. So here in this case we are given the option as post order and the in order, so clearly it will be the answer. So moving to the next question. The process of accessing data stored in a serial access memory is similar to manipulating data on a, and here we are given the data stored in a serial access memory. So here serial access can be that is be storing the data. Firstly we'll be storing at a position, and then we'll be storing at the back of that, means sequentially accessing the data. So it can be similar to the stack, where we'll be pushing the data in the last in first out manner, and the element that is pushed initially, the first element that is pushed will be accessed at the last. And similarly here there is the process that is accessing of data in serial access. Here also the element that are pushed at the last will be accessed first, and the element that are pushed first will be accessed at the last. So here it is following the property of a stack. So clearly the stack is the answer here. Now moving to the next question. We are given the prefix form of we are given the infix order, and we have to find its prefix. So let me write the example here. Prefix is something that is we are given the infix order and we have to find its prefix. So you can do it using the algorithm, or you can do it using the associative property of the operators. So I will be discussing with using the associative property. So let me discuss the given question here. Okay, so here we are given the infix order, that is A minus P, then here we are given C asterisk D slash E. So here the highest priority will be of bracket, so we'll be firstly for solving the bracket. So in the first step will be A minus B, and then C, okay, then this, and then we'll be solving the bracket. So in bracket we'll be getting the pre-order traversal as we'll be moving this to this position, and then this to this position. So here we'll be getting C D asterisk at the start, and then we'll be getting C, okay, here we will be getting C XOR DE. This will be the case, and then since the bracket is solved, so we'll be removing this bracket, and then we are left with this much bracket. So here we are getting so let me solve this first part here. So it will be minus of AB, and then the third position will be left with star C asterisk D E. So this is the left that we have to perform. This is the second step. Now in the third step, we have don't have we haven't shifted this division sign, so we'll be shifting this at the position here. So it will be minus A slash B, and then we'll be having the similar what is left here, C and slash D E. So this will be the clearly uh, prefix order here, prefix order. We have shifted all the operators at the position between the two operands. We have shifted all the operators to initial of that operands. So in that case we'll be getting the prefix order. So clearly our answer will be in this case that is minus A slash B star asterisk C and then C and cap then DE. So this will be the our answer in this case. Now moving to the next question. What is the time complexity of adding an element to the heap? So considering the heap element, here we can have two operations, that is two time complexities. Considering the two cases, suppose the heap is the balanced. So in that case, suppose we have been given this balanced heap. Okay, this is the suppose the given heap, and here we have to insert an element, that is suppose this is 1 2 3 4 5 6 7, and here we have to insert suppose an element, that is 0. Okay, so clearly if we consider this as min heap, so its position will be at the root. Okay, so in that case we have to go through all levels one by one, and at each level we will be checking the only one node. So its time complexity in balance will be log of n, that will be height of the given heap. And if we consider the example, that is if it is not balanced, in that case suppose if it is a skewed heap, so in that case the height will be clearly equal to the number of nodes. So in that case we have to suppose again considering the same example, that is 1 2 3 and 4. Okay, and now we have to insert the element 0 here. So again we have to move through all the positions, and here the height is equal to O of that is height of number of nodes, so it will be clearly of O of n. So here we have two complexities, that is O of log n and O of n. So that will be the case here. So that's the answer here, that is O of log n and O of n. So yeah, moving to the next question. What is the need of a circular queue? So firstly we need to understand what is a circular queue. Circular queue is a queue that is having suppose the queue in this manner. Here we have the all the nodes connected, and here we are okay, let's consider the queue. Here we have all the nodes connected, that is there is no start or the end positions. We can start from any position and we can end at any position. So suppose considering this as the starting and ending position, initially we'll be filling all the elements, and here there is no space wastage. Suppose if we consider this normal queue, in that case if we are starting from this position and then at this position we have filled. Now if we want to insert at any animal element, in that case we will not be able to insert that element, because here the rear will be equal to the n position, that is the size of the queue, and if the rear is equal to n, in that case we can't insert the element because there is no element no space left at the rear end. And if we can see, there is a space at the starting position, but we can't insert the element here because we can insert only from the rear end. But in case of circular queue, we can insert the element at any end, because here there is no end of the queue. We can insert while the space is left. So here we can insert 7, then 8, and now the when the front and the rear are equal, in that case will be here the front and the rear, means rear equals to front plus 1, or the front is equals to rear plus 1. In that case, circular queue is considered as full, so in that case we can't insert the element. So that will be the case here, that we can't insert. And if we remove any element, then we can insert. Suppose if we remove this one, so in that case we can insert the element. So this is the benefit of the circular queue. So let's check from the exam given options. Effective usage of memory, yes, this can be the answer. Easier computations, might be, but the more effective answer will be the first case. To delete elements based on priority, no, this is not the case. Implement LIFO property in queues, no, can also not be the case. We have the answer as effective usage of memory. uh, Now moving to the next question. What are the advantages of array? So array can firstly you need to understand what is the array. So array here is the linear data structure. Linear data structure, that is it can store homogeneous element in the sequential manner. So homogeneous here means the same type of data it can store. Suppose it is storing if integers, so it can only store the integers, that is 1 2 3 4 5 and 6. And sequential means here if the memory size first for the first memory block it is stored at the index 1000, so next will be stored at the index 1004, next will be at 1008, and so on. So here there is a continuous memory space. So this is the more about the array data structure here. So let's check the examples. So objects of mixed data type, no, it can't be stored, because here we as I have mentioned, we can store only the homogeneous elements in the array cannot be sorted. No, this can also not be case. Index of the first element of the array is 1. Either ideally it is not the case. If we consider the example, uh, then we can consider, but ideally it is starts from the index 0, and easier to store elements of same data type. Yeah, this is the case. We can store the homogeneous data elements or the similar type of data elements. So this will be our answer. So moving to the next question. What differentiates a circular linked list from a normal linked list? So here you have been given the options as you cannot have the next pointer linked to a circular linked list. Okay. In circular linked list also you can have the null pointer, because if any node that is next to it is null, in that case you can have the next pointer as a null. So this is not the case. It is faster to traverse the circular linked list. No, there is nothing like that. You can traverse the both the linked list as per the same speed, depend upon what logic you are applying. Next, you may or may not have the next pointer to null in a circular link. Yeah, it is very true, because you can have there is a liability in the circular linked list that you can have the null pointer or you can't have, because if each and every node is pointing to the next node, and there is a circular fashion, means suppose as we have considered the circular, suppose this is a circular linked list, and here we each and every node has the next pointer pointing to the other node. And for 8, suppose this is the last node, so here 8 will be pointing the very first node, that is in this case will be 1. So clearly we can have the liability here that we can point to the next null, or the circular linked list can point to the next node also. Head node is known in the circular, head node is known in the both the list. So here it is not the case. So clearly our answer will be in this case the third option, that is you may or may not have the next pointer point to null in the circular linked list. Moving to the next question. So this is the, I think, the last question of this question, this live session. Which data structure can be used to test a palindrome? So here, firstly we need to understand what is the palindrome. If you have the idea, then you can okay. Then it is okay. If you don't have the idea, suppose we are given the string as A B B A. So clearly it is a palindrome, because if we consider this as a point, so for this AB here is the left side, and here we have BA at the right side. So clearly they are at the this line is the clearly the mirror image of the both side. Here we have the AB and here we have the BA. So if this can happen in a string or given array, then it is considered as a palindrome. Means it is for at any point it will be left and the right side will be same. So in that case it will be a palindrome. So clearly we can use the stack data structure to implement to check whether it is a palindrome or not. So let me check. Suppose we are given the string as s equals to a b b a. So in this case we'll be pushing all the nodes starting from the first position into the stack. Okay, so here a will be pushed, and next b will be pushed, next b will be pushed, and next a will be pushed. So clearly our stack in this case will be equals to a b b a. And now when we pop this data structure and append it to the suppose a new string, suppose let's consider answer, and now we'll be popping from the starting position, that is top positions. So a will be popped and a will be appended to this. Now b will be appended to the back of this string, so b will be there. Now b is also popped. Now this b is also popped and it will be appended to the back positions. Now a will be popped and this answer will be equals to a b b a, and this is clearly equals to the s string that we have considered initially. So if this is the case, then we have the palindromic string, and if it is not the case, then we can say that this the given string is not a palindromic. So for implementing that, we can use a stack here. So let's check the answer here, and it is clearly equals to stack. So I'm done with the you can hope these type of questions and the given context also, and you can there can be a slight change in the questions that you have to observe there, and means these type of questions will be asked in the actual contest there. So you can prepare these questions, uh, and we hope you active participation in the contest. So that will be the case, and if you have any doubt, you can ask in the comment section of the this video. So if after the live contest also, you can ask the question and I will be replying if you have any doubt. And related to the contest, you can participate it on 26th August of this, that is 26th of this month, and hope the active participation of all the candidates. And today I have discussed the computer science fundamentals, and tomorrow we might be discussing the coding and the aptitude questions. So be there and keep track of the questions so that you can prepare better. Okay, so let me end the session. Thank you.